Okay, hello and welcome, or welcome back if you've joined us previously for a BBA webinar. What are we talking about today? Well, we're talking about startups, sustainability and mushrooms. Believe it or not, yes, we are. I'm delighted to be joined by Ahab Syed, the founder and director of innovation at BIOHM. They're an R&D-led biomanufacturing company, of which I won't spoil or steal any of his thunder. We'll get onto that later. First and foremost, I'm just going to do my little bit of BBA admin, if you don't mind, before we get onto the good stuff. So who are the BBA? If you don't know, if you've joined us before, apologies, you've heard this a lot. But if you haven't, it's new, fantastic. The BBA have been around for over 50 years, and with the premise of helping construction and manufacturing industries build confidence in the solutions they provide, the services, the products they build, and that confidence emanates throughout the entire supply chain. The BBA look to build long-term partnerships with clients and associations, and we want to continue the growth both in the UK and in global marketplaces throughout the construction industry. But it's important and critical that we remain reassuringly impartial. We're a for-profit organisation limited by guarantee, so we look to reinvest into the industry as a whole that benefits all stakeholders, which includes everybody that I'm delighted to say has joined us today. Thank you so much. But what do the BBA do? Well, fundamentally, and probably what we're best known for is our BBA agreement certification. We do product approval certification, that includes the agreement, as well as reproduction and HAPAS. But we also do other or provide other services to the industry, such as testing, audit and inspection, and management services, and most recently, UKCA marking or conformity for UKCA marking. So there's a lot more to the BBA than some people might realise. So I just wanted to highlight that to everybody on the call. To date, we've issued over 6,000 certificates, over 1,000 annual inspections, and we've got over 72 countries represented by our client base, which is pretty cool. Okay, so that's enough about the BBA. So I want to dive into today's topic, which we slightly covered in the first slide, but a little bit more info before I hand over. So what we'll cover today is we'll look at how nature can be inspirational. We'll look at sustainability, startups, and the construction industry. We'll address sustainability challenges head-on as a startup, as BIOHM, approaches to and supporting product innovation, and we'll end with a Q&A. So if you've got any questions throughout the entire presentation, I won't stop it. We'll leave them to the end, and then we'll get to them. If we don't get a chance to ask any questions, we promise we'll get back to you after the presentation, before the end of the week, because sometimes it just isn't, we can't get through all questions. It isn't possible just to time constraints. We've only got half an hour. We really appreciate that your time is limited, so we want to add as much value and impact as possible. That said, I'm going to hand over to our presenter today, Ehab. So Ehab, welcome. And I'm going to hand you, there you go. You should have control of the screen, so you should be able to take over now.
Great, thank you. Hello, everyone. So I'm just going to share my screen. Hopefully you can see my presentation now. Right. Hi, I'm Ehab Syed. I'm the founder and director of innovation at BIOHM, board member of Fast Forward 2030, and PhD researcher at Northumbria University. Today, I'd like to share how nature is inspiring us to revolutionize the built environment and restore local equity. We're living through quite a critical and unprecedented time for humanity. Whilst we once lived our lives as a part of the natural world, the world we've built for ourselves is marked by a form of extraction and consumption, driven by man-made stories that we've collectively believed. Stories that prioritize economic growth, individual wealth, and power. Stories that have shaped our economic systems. The climate emergency, the biodiversity crisis, social injustice, and arguably the pandemic that are all wreaking havoc around the globe may all be perceived to be the interlinked ripples caused by the models, products, processes, and the economic systems that we've created. And whilst awareness of such existential crises is at an all-time high, our habitats and our species are predicted to grow by a further 40% in the next few decades. This growth is currently supported by extractive and wasteful practices that are evident across all industries. But the construction industry is one of the largest contributors to the climate crisis. The World Economic Forum has highlighted the industry's waste as a major sustainability challenge, with annual waste figures expected to rise to 2.2 billion tons per year by 2025. Agricultural and food systems are also major contributors, with a staggering 1.3 billion tons, or a third of all food produced globally, being wasted. This seeming lack of appreciation for resources is further emphasized by the realization that the combined infrastructure plans of developing nations would require another 7 planets worth of resources. This, coupled with the fact that the world's richest 1% now own as much wealth as the other 7.7 billion people, and that 1 in every 9 people around the globe go to sleep hungry each night, really highlights the major social, economic, and environmental injustice born out of our current economic systems. But instead of man-made stories, what if biological systems and ecological laws were the driving force of our economy, eliminating the concept of waste and ensuring equity and equilibrium are achieved in all ecosystems? Well, that's exactly what we do at BIOHM, a multi-award-winning research and development-led company that is driving a bio-revolution in the built environment and the way we do business. We're driven by a very simple philosophy: to allow nature to lead innovation and only have a positive or regenerative impact on everything we touch. And this philosophy or algorithm is manifested through all of our offerings. Our bio-based materials, which can be used in the building fabric and interiors, as well as wastewater treatment, our construction systems, which erect buildings, and a range of services, including waste or resource management and consultancy. Now we're starting with the most tangible and immediate of these offerings, and that's our bio-based materials. We work with one of nature's most wondrous organisms, mushrooms. We use the mycelium, which is the root systems or vegetative part of fungi, and the outcome is one of the world's most advanced building insulation materials. We've developed biologically unique strains of mycelium that we've naturally accelerated their evolution to favor particular traits that would improve their mechanical and physical properties. And we train them to consume a variety of waste streams and industrial byproducts. When testing our mycelium insulation against construction industry standards in-house with research institutes, as well as of course with BBA and BRE, we were blown away by how our materials were outperforming market-leading synthetic and natural insulation, as well as realizing that our materials are some of the healthiest materials available. No additives, no chemicals, outperforming other products on the market on almost every property by simply using nature's genius. As a startup and newcomer to the industry, it can be quite intimidating entering such an established market, but it is through the rigorous science and objective testing that one can gain confidence and take an evidence-based approach to proving how we can hit our global social and environmental targets without compromising on building performance. Now, you may be aware of mycelium's remediation capabilities, known as mycoremediation, which is a process by which fungi produce enzymes that can break down complex compounds like plastics into hydrocarbons, sugars, and carbon dioxide. Well, we've developed mycelium strains that are capable of consuming plastic. In 2019, we were awarded the Waitrose and Partners Plan Plastic Prize to develop this research further. This has allowed us to carry out a series of experiments where we continue to evolve our strains through a non-intrusive and non-GM process known as directed evolution, which basically mimics the process of natural evolution but in an accelerated lab environment. And this has resulted in the development of 4 strains that can successfully consume PE, polyethylene, and PU, polyurethane. Unlike other end-of-life solutions for plastic, which can propagate the current plastic crisis, our process eliminates plastic completely, and the applications are endless for this technology. We're in discussions with airports and water management organizations about using our Mycelium strains for wastewater and contaminated soil treatment, and are currently in discussions with industry giants from construction, fashion, and tech to actually literally consume their plastic products at end of life. We also aim to eventually integrate plastics and other synthetic waste streams from various sectors into our large-scale material production process, which uniquely recirculates and consumes all of its outputs, turning our production facilities, known as biomills, into carbon sinks. We've also developed ORB, or organic refuse biocompound, which is a semi-structural material that can be pressed into sheets, molded into 3D shapes, extruded, or 3D printed. It is made entirely out of excess resources and byproducts from food and agriculture, such as orange peel, cocoa husks, coffee chaff, or grass trimmings. These waste streams are mixed with a 100% natural binder that we've developed, which is also derived from food and agricultural waste streams. It's currently available for use in interior architecture, furniture, and small-scale bespoke building projects, and will soon be available at scale for interior walls or dry lining in buildings. It outperforms other wood-based sheet materials, it is carbon negative, doesn't contain any synthetic chemicals or toxins, and is highly price competitive. Or will follow our mycelium insulation when it comes to scaling industry accreditation and commercialization. And it will soon be forming the walls of the new and completely circular Glyndebourne Opera Pavilion, which will also feature our mycelium insulation. We're also incorporating other waste streams like excavated and contaminated soil, leading to some exciting breakthroughs in our journey to develop ORB into a plant-based concrete over the next couple of years, which will be a serious game changer. Although our materials are designed to be seamlessly integrated into current practice, we've developed Triagony, an interlocking construction system that combines all of our materials and is inspired by the way carbon molecules bond to one another. It doesn't require any permanent binders or fasteners to create robust structures that can be deconstructed at any stage of their life, allowing buildings to grow, shrink, and adapt to the needs of their occupants and local community. It reduces build times by 95%, build costs by 70%, and the environmental impact by a staggering 120% when compared to brick and block construction. It's patented in all continents in almost 60 countries, and we aim to launch Triagony with our plant-based concrete in around 2 to 3 years from now. Our mycelium insulation is a material, its uniquely scalable production process, and our approaches to evolving and training our strains have all been patented, with more patents covering our biotechnologies to come. And much like we did with our Triagony patent, they will all be expanded worldwide. But due to the vast environmental benefits and global potential of our biotechnologies, it was essential for us to deliver them to the world in a way that is ethical, equitable, and sensitive to our post-pandemic economic landscape. So we've just successfully completed the final trials of our demonstration production facility in Watchet, West Somerset, and we'll be opening the doors to our first large-scale biomill at the start of 2022 in the southeast of the UK. Apart from being the first large-scale facility to produce accredited mycelium insulation, another unique aspect is in the way it acts as a catalyst for regeneration within a community. Again, taking inspiration from nature, we've developed a business model that allows communities to drive industry in quite a revolutionary way. So although we patent our technologies to protect ourselves, we scale them by making them available to disadvantaged communities around the globe. We're basically hacking the system by indirectly open sourcing our biotechnologies, which are really owned by nature to benefit communities that need it the most. And in doing so, we've stumbled into a growth hack, enabling us to rapidly scale. By the start of 2022, our first biomill will provide enough insulation for up to 30 homes per month, and over the next year or so will be scaled to provide enough insulation for 120 homes each month. At that scale, we would be consuming around 240 tons of waste and sequestering around 30 tons of carbon. That's equivalent to the monthly carbon sequestration efforts of 19,000 trees. Every square meter of material we produce sequesters as much carbon as a fully grown tree does in 1 month. And each biomill will provide over 30 new local jobs, and through the distribution of profits, provide a constant income for the community, allowing them to invest in education, entrepreneurship, infrastructure, and social action projects. We're also working with the YMCA Newcastle to set up the second biomill in the north of the UK next year, and have been invited to set up more biomills by governments and organisations around the globe to address the overwhelming demand for our materials and for regenerative impact. You can see here just how significant our impact can be through scaling. With 44 biomills, we would be insulating over 60,000 homes, consuming almost 130,000 tons of waste, sequestering almost 16,000 tons of carbon, and providing almost £30 million to disadvantaged communities on an annual basis, as well as creating over 1,300 multi-skilled jobs with clear career development paths. And our services enable us to maximize this impact. We offer biomimicry and circular economy consultancy services that are closely linked to our biotechnologies. They enable us to integrate major multinationals' waste streams into our material production processes and enable them to meet their carbon circularity, resource management, and regeneration targets genuinely. Our consultancy work also allows giant and influential industry players to integrate biomimetic practices in their operations, highlighting the benefits of biomimicry to the industry and the general public. A critical step for any innovation to penetrate the market and gain credibility is compliance with industry standards and accreditation, which is actually a very challenging process when you're working with a completely new biotechnology that's a little bizarre and sci-fi. We create mushrooms that consume plastic and turn them into a high-performance building material. But British Board of Agremon, or BBA, have been incredibly supportive throughout the process and have ensured that accreditation can be a powerful driver for the uptake of new disruptive innovations rather than being a barrier. We will have fully certified data sheets imminently and aim to have our full BBA accreditation hopefully by the start of 2022 in time for our production to be up and running. Along with government support, we're working with Europe's top universities, some of the world's largest multinationals, including the UK's largest property developer, global architecture firms, and tech giants, and have been awarded and recognised for our work by national and international bodies. Collectively, we're working towards a biomimetic future. A biomimetic future will allow us to make leaps in the fight against the climate crisis, equitably distribute wealth, and showcase a new global economy that benefits from global interconnectedness and the sharing of knowledge, and works with more reliable local supply chains and empowers local communities. A biomimetic future will allow us to be that species that healed the planet they almost lost and secured our future, the future of home. That brings me to the end of my presentation, so please feel free to ask any questions.
Fantastic. Thank you so much for that presentation. It's always interesting to see new innovative products looking to come to market, and it's always fascinating to see the development of those. I've got a few questions, if you don't mind. The first one, and this might sound really rudimental for you, I'm not sure, but how did you come to realize that mushrooms could do or could help the construction industry and sustainability?
Right. That's actually a really interesting question, because if you look around you, or if you go for a walk in the forest, for example, you will see that mushrooms are doing their job at biodegrading and almost enabling circularity within nature. Our lead biotechnology engineer calls them nature's greatest janitors, because they basically just take all of the waste streams and turn them into new products for other organisms. So knowing that and having that knowledge, I think mushrooms always held the key to breaking down different products and substances in nature, but then they also create such a wide variety of materials. So they create everything from slime mold, which has very different properties, to something like turkey tail mushroom, which is very rigid and hard. And knowing that kind of opened up the spectrum of exploring what we can do with mycelium and mushrooms in order to create new materials and products that are actually working with nature and using nature's genius, rather than working against nature or just creating things that nature isn't very familiar with.
Really, really interesting. So I just want to take it back one step and focus on the construction industry, if you like. As a startup, new innovative products, what have been the challenges of trying to highlight what you're doing, but also just breaking into the construction industry with new innovative products?
Yes, I think the construction industry, unlike the automotive or other industries that kind of have an innovation culture that's very rife. If you look at percentage of investment in innovation in other industries, it's in the 30–40%. In construction, it's more around the 3 to 4%. And of course, that's a massive generalization from research, but the kind of culture of innovation and taking up new disruptive technologies, it usually takes a much longer time when you're dealing with construction than you are with other consumer products or automotive. And the reason for that, I think, is the risk in construction is much higher. So when you're building a building, you don't really want to cause any risks that may harm people's lives, or may also create all kinds of disasters like we've seen happen in the past. So because of that really kind of risk-averse approach, quite rightfully so, and the kind of culture of innovation not being at the forefront, it was actually a really challenging process. And you've seen a lot of startups that start in trying to bring a construction product to market, but then pivot towards something else that is a bit easier to address. But I think like I said in my presentation, when we started the testing process and being incredibly rigorous, scientific and objective about our approach, we kind of let the figures and numbers and test results that we got speak for themselves. And that then created the kind of change in perception of actually a natural material can perform just as well as the plastics that we're used to or the metals that we're used to, or it can give you the same kind of level of performance but actually be much healthier for you. And that's when we felt that the larger industry players started to listen to us. And with the support of BBA and going through the testing process, that just created a whole other level of credibility. Even just starting to engage with the BBA was a huge level of credibility for us.
Okay, excellent. I've got a few questions from the audience. You'll just have to bear with me because I can't see the whole question here. So, Debbie was asking, how easy will it be to scale up the production of mycelium products? And would this involve a few large factories or many smaller local ones?
That's a really great question, Debbie. Thank you for that. So in general, mycelium as a process, it's very different to kind of making a synthetic insulation product. And the reason for that is because it's grown. You're working with a living organism, you're speaking to it, you're letting it kind of understand how it needs to perform and grow to create the perfect product. Therefore, the process can be thought of more like vertical gardening rather than a kind of forceful production process. So we create kind of vertical approaches to growing our insulation panels, and we're able to grow 1 panel or 1,000 panels or 1,000,000 panels in the same time frame of about between 1 week to 30 days, depending on the waste stream we're working with and the strain of mycelium we've got. Now, we've developed a lot of IP in the production process that enables us to scale quite rapidly. And that means that our first production facility that's going to be at 30 homes per month is going to be the smallest facility we will ever create. And we're going to be looking at 120 homes per month being the minimum for every production facility. And instead of having huge production facilities that are shipping product all around the world and around the country, we're going to be taking a very hyper-localized and decentralized approach to production, where we're setting up lots of smaller production facilities ironically kind of like mycelium does in nature. So you've got lots of networks of mycelium in a forest, and we're only taking waste streams from the local area, so about 60-mile radius, and only serving projects that are within the local vicinity. So a very localized approach, which massively improves, emissions, environmental performance, but also enables the value that's created locally to be maintained locally, and therefore improve the economics in the local area as well.
Excellent, thank you for that. Just a couple of other questions about product specifics, really.
Yeah.
Quite a simple one from Eric. Is the building material and insulation moisture resistant?
Yes, so mycelium naturally is hydrophobic, so it can float in water if you look at 100% mycelium. But because we feed it waste streams and we keep some of those waste streams in the end product after they've been obviously through a process of pasteurization, we have the kind of hydrophilic waste stream and the hydrophobic mycelium within the same material. So it's not completely hydrophobic as an insulation product, but it's self-wicking and it has really good moisture resistance. So all of the initial testing we've done on moisture and hygrothermal properties have all passed with flying colors. So I think in terms of, from that perspective, it performs just as well, if not better, than other products because of the breathability and self-wicking nature of the material.
Okay, I think we'll finish with this question because it kind of rounds it off quite nicely from Tom. And Tom asks, how does the longevity of the insulation and structural products compare to the standard materials we use at the moment? Do we need to think about shorter design? Do we need to think about shorter design life buildings or not?
Really, really good question. A very kind of philosophical thought for the industry as well. We build buildings that last between 5, 15, 30 years, especially in big cities like London, and we put materials in them that last for hundreds or thousands of years. So I think we need to rethink the way we're matching the material life cycle with the building life cycle. But at the same time, we also need to make sure that that risk is not there for the material to perform just as well throughout its entire life. So the tests that we have access to have shown that a piece of mycelium insulation can last for 8 years or so without deteriorating in performance, whereas a plastic insulation, for example, can start to deteriorate after 5 years. So from that, you can deduce that it's kind of similar performance or it can last just as long. And we're also in discussions, of course, with warranty providers and providing them those results for reassurance. But I think the perception of bio-based materials, because they're biodegradable, they can last, not last as long, is something that we need to examine further, because it's only in the soil with the right microbiome that the material will biodegrade. Otherwise, it will continue to perform and last just as long as other materials.
Fantastic. I think we'll finish that. It's a nice way to round off the webinar. Ehab, thank you so much for joining us. Absolute pleasure, really interesting, all the innovation that's going on with nature, sustainability and innovation just within our industry, really. It's always really good to hear that. So thank you for joining us.
Thank you for having me.
And finally, from the people that asked the questions and everybody else in the audience that's joined us for the full half hour, from the BBA, from BIOHM, Ehab, myself, thank you so much for joining us. If you want to know what's coming up in webinars this month and throughout the entire year and into 2022, check out the website, BBA website. Got some really interesting talks coming up. Yep, and if you've got any further questions that we didn't ask, we will get back in touch with you with an answer, because we think that's hugely important. So finally, from myself, BBA, Ehab and BIOHM, have a great day and thank you very much for joining us.
Thank you all. Bye-bye.